Now let's apply the idea of directed graphs and r-step connections to a real-life example. A Penn student suddenly has to figure out how to make it back home to Tampa, Florida. Due to COVID-19 fears, regulations cause certain airports to restrict incoming flights. What is the least number of flights that the Penn student must take to make it home? So here we have a directed graph where each vertex or point represents an airport at some city in the US, and we're starting at P1, Philadelphia, and we're trying to find the shortest path or least number of flights to make it a P5, Tampa, in which case we can use linear algebra and matrix multiplication. We can represent this directed graph as a matrix, marking one where there is a directed edge from one vertex to another. So as we can see at M15, there is a 0, meaning that there are 0 one-step connections from P1 to P5. We can square this matrix to find the number of two-step connections and see if the index M15 is non-zero. For M squared, we see that the index is still 0, so we can raise this matrix to the third power to see if there are any three-step connections from P1 to P5. Finally, we can see that there are two three-step connections from P1 to P5. We can verify this graphically, and we can see that there is a path from Philly to New York to Houston to Tampa. And there's a path from Philly to Los Angeles to Houston to Tampa. So our fellow Penn student has two ways to make it home in 3 flights.